viewers. In today's session, we are going to discuss another important and conceptual problem from definite integrals. And in this session, we are going to solve this problem in which we are given two functions f of x and g of x such that f of x plus 2 times g of x is equal to e raised to minus x, and the derivative of f of x, that is f prime of x, is equal to f of x with f of 0 is equal to 1, right? So here we are given these three conditions, and we have to find out the value of this integral, that is 0 to 1 square of f of x times g of x dx, right? So let us see how we can find out the value of this definite integral using these three conditions. So let us take this integral as I, right? And here we'll start with these two conditions. So here we are given f prime of x is equal to f of x, right? So we can now solve this equation. This is a differential equation of first degree and first order, right? So here we have a df over a dx is equal to f, right? So here we are writing f of x as f. So f prime of x is equal to f of x can also be written like this. So now separating the variables, here we can write df over f, and here we have dx. So let us integrate both sides. So we can now write integral df over f, and here we have integral dx, and c is the constant of integration. So here the integral 1 over f df is simply a log of f, and here we have x plus c, right? So let us again replace this f by f of x. So we have natural log of f of x is equal to x plus c, right? So now let us use this condition to find out the value of this c, that is constant of integration. So we have f of 0 is equal to 1. So let us take x is equal to 0 in this condition, or in this equation. So we have a natural log of f of 0 is equal to 0 plus c, and f of 0 is 1. So we have log of 1 is equal to c, and log of 1 is 0. So the value of c is equal to 0. So let us substitute this value in this equation. So we have natural log of f of x is equal to x plus 0, that is simply x, right? So now we have natural log of f of x is equal to x. Now taking the exponential of both sides, we have e raised to natural log of f of x is equal to e raised to x, and e raised to natural log of f of x is simply f of x, that is equal to e raised to x. So the function f of x is an exponential function, so f of x is equal to e raised to x. So let us substitute f of x in this equation. So we have e raised to x plus 2 times g of x is equal to e raised to minus x, and 2 times g of x is equal to e raised to minus x minus e raised to x. So g of x is equal to e raised to minus x minus e raised to x over 2, right? So now we have obtained the values of f of x and g of x. So let us substitute these two functions in this integral. So now we can write I is equal to integral from 0 to 1 and square of f of x, that is e raised to x square, and for gx we have e raised to minus x minus e raised to x over 2, and here we have dx. So let us simplify it. We can take half outside the integral. We have 0 to 1 e raised to 2x, and here we have e raised to minus x minus e raised to x dx. So we can now write half 0 to 1, and multiplying these two quantities by e raised to 2x, we have e raised to 2x minus x, then we have e raised to 2x plus x, right? Okay, so now we can write this integral as half, and we have 0 to 1, and e raised to 2x minus x is simply e raised to x, and here we have minus e raised to 2x plus x is e raised to 3x, and here we have dx. So now let us simply find out the value of this integral. So we have I half the integral of e raised to x is simply e raised to x, and the integral of e raised to 3x is e raised to 3x over 3, and the limits of integration are from 0 to 1. So here we have used these two results. The integral of e raised to t dt is equal to e raised to t, and the integral e raised to say m times t dt is equal to e raised to m times t divided by m. So here the value of m is 3, right? Okay, so now we can substitute the limits and we'll take the difference. So first we'll take x is equal to 1. So we have e raised to 1 minus e raised to 3 over 3, and then we have here x is equal to 0. So we have e raised to 0 minus e raised to 0 over 3. So this is half, and we have here e minus e cube over 3 minus here we have e raised to 0 is 1. Here also e raised to 0 is 1. So we have 1 minus 1 over 3, that is 2 over 3. So here we have 2 over 3. So let us simplify this expression. So we have I, and we have half, and 3e minus e cube minus 2 over 3. So we can write I is equal to 3e minus e cube minus 2 divided by 2 times 3 is 6. So this is the required value of this integral I when we are given two functions f of x and g of x, such that f of x plus 2 times g of x is equal to e raised to minus x, and f prime of x is equal to f of x, and f of 0 is equal to 1. So this is how, by making use of these concepts, we can easily solve these kind of problems. Hello viewers, in today's session we are going to discuss an important and conceptual problem from derivatives, and here we are going to solve this problem where we are given a function f of x which is equal to e raised to a maximum of x square comma fractional part of x for all x belonging to the interval that is 0 comma 1. So here 0 is included and 1 is not included, and we have to find the derivative of f of x at x is equal to half, right? So let us see how we can solve this problem using the concept of maximum of two quantities a and b. So now let us consider two quantities a and b, right? And the maximum of the quantities a and b is defined by this expression, that is half and a plus b plus mod of a minus b, right? So here we'll first simplify or modify this function f of x using this result. So here we have maximum of x square and fractional part of x, right? So here we can write maximum of x square and fractional part of x using this result as half, and then we can take a is equal to x square and b is equal to a fractional part of x. So we have x square plus fractional part of x, substituting the values of a and b in this result, and then we have a mod of x square minus fractional part of x, right? So now we have to simplify this expression, and here we'll make use of the definition of fractional part of x in terms of greatest integer function. So the fractional part of x is defined as x minus greatest integer of x. So we can now write half, and here we have x square, and for fractional part of x we can write x minus greatest integer of x, and then here we have x square minus fractional part of x. So here multiplying fractional part of x by negative sign, we have minus x, and then we have plus greatest integer of x. So now we have here this interval, that is x belonging to the interval 0 comma 1, that is x is greater than or equal to 0 but less than 1, right? So whenever x lies between 0 and 1, then the greatest integer of x is always going to be 0, right? So this is an important step here. So replacing greatest integer of x by 0, we have half, then we can write x square plus x minus 0 plus mod of x square minus x plus 0, and we can now write half x square plus x plus mod of x square minus x. So now to simplify a mod of x square minus x in this interval, let us make use of the definition of mod function. Now the definition of mod function is the mod of p is the positive p whenever p is greater than 0, mod of p is 0 whenever p is equal to 0, and mod of p is negative p whenever p is less than 0. So here we have a mod of x square minus x. So x square minus x can be written as x times x minus 1, right? And now see here x lies between 0 and 1, right? So all the values of x which lies between 0 and 1, it makes this quantity, that is x minus 1, as a negative quantity, right? Because whenever we take x lying between 0 and 1 including 0, then x minus 1 is always going to be a negative quantity, but x is a positive quantity. So here we can write positive times a negative, so this becomes a negative, right? So x square minus x is always going to be less than 0 for all x belonging to this interval, that is 0 comma 1, right? So using this definition of mod function, we can now write mod of x square minus x is equal to a negative of x square minus x whenever x square minus x is less than 0, right? So now replacing mod of x square minus x by a negative of x square minus x, that is minus x square plus x. Now a maximum of x square comma fractional part of x, it becomes half, and here we have x square plus x, and mod of x square minus x is negative x square plus x, right? So now simplifying it, these two quantities get cancelled and we have half and x plus x. So this is half and x plus x is 2x. 2 and 2 get cancelled and we are left with only x, right? So this quantity, that is maximum of x square comma fractional part of x, is equal to x. So now our function f of x can be defined as e raised to maximum of x square and fractional part of x, which is equal to x. So here we have x for all x belonging to the interval 0 comma 1. So now what we have done here, we have modified this function using the concept of maximum of a comma b, using this result. So we have f of x is equal to e raised to x. So if we differentiate it, then f prime of x is d by dx of e raised to x, and the derivative of e raised to x is e raised to x. And we have to find f prime of x at x is equal to half. So taking x is equal to half in this expression, we have f prime of half is equal to e raised to half, right? Which can also be written as square root of e. So the derivative of f of x at x is equal to half is equal to square root of e.